we'll compare the magnitude of these frictions. The static friction, sliding friction, and rolling friction. Sliding and rolling friction. All these three frictions are having different magnitudes. Friction, as you know, it is opposing force. Static friction, at rest, it is opposing. Sliding, while the object is sliding, there is opposite force. For the sliding, it opposes. For the rolling, the surface opposes. All are having different magnitude. One is greatest, and one is least. Now we must find which is greatest and which is least. Here this is written in the same order. That is, we can say it is in the descending order. The maximum value of friction is static, and then sliding, and then rolling. So rolling friction is the least. If we write in the order, rolling friction, it is least, then sliding, then static. So static friction is highest, greatest. Rolling friction is the least. Here we must discuss why static is highest, it is smallest. That is to be discussed. Now let us discuss the reason why static friction is the highest value, having the highest value. We take this the example. Now you see, the block, it is placed on the surface at rest, and we know the cause of friction. Why the friction arises between? Because the irregularities present on the surface and on the surface of block. That irregularities of both the surfaces got interlocked. Then the friction arises. If the interlocking is stronger, friction is higher. Interlocking is weaker, friction is lesser. Here it is at rest. The block is at rest. And this surface, this amount of surface, this extent of surface is in contact with the ground surface or the table surface. And these irregularities on the block and the surface got sufficient time, excess time for the interlocking. When the irregularities get sufficient enough time for the interlocking, then the interlocking becomes stronger, then the friction is also greater. But in sliding, what happens? The same block, when it is sliding, when it is moving on the surface, the surface of block is moving on the ground. Here the same part of the block is in contact with the surface, but as it is moving, it is continuously changing. It is continuously changing the surface of contact. Continuously, surface of contact is changing. Here the same surfaces of ground and the block are in contact forever, continuously. But here the surface of contact is changing. Because of the change of surface of contact, the two surfaces get less time for the interlocking. Because of the less time for the interlocking, the friction is less than the static friction. Then coming for the rolling, the ball, it is rolling. Now we take 4 points, suppose A, B, C, D. When the block is rolling, suppose it is rolling in this manner. Now the point A of the ball is in contact with the surface at this point. If it rolls means it rotate and also move on the straight line. After some time, we find the surface of ball which comes in contact with the ground, that is D point will come in contact. A will come here and B, C. In the next instant you find C will be in contact. C will be in contact. B. And then B will come in contact. As the ball rolls on the ground continuously, we find the ground surface and the surface on the ball, both are changing continuously. In this case, same surface at the same place. Here, the surface, same surface of block changing on the ground. Here, the ground surface and the ball surface both are changing continuously. New surfaces are coming in contact with each other, and that too also for very small time. As the ball rolls, the surface in contact is for very small time. In that very small time, the interlocking become weaker and weaker. That's why in this case, the surfaces get very least time for the interlocking, so the friction is least. So here the main thing for the difference is the time for the interlocking, time available for the interlocking between the two surfaces. While they are at rest, they get very higher time, less time and least time. That's why rolling friction is least, static friction is most. And this is the reason why sliding is less than static, rolling is less than sliding, rolling is less than static. This is how we explained the order of frictions. Next we will see that because of the least value of rolling friction, we use this phenomenon in our practical examples. That we will see in the next session.